Question 1. A new technician is assigned to the low-temperature sterilization area. The clinical educator emphasizes strict adherence to safety and handling protocols. Why is this comprehensive training primarily mandated for these specific modalities compared to standard steam processing? A. The chemical agents utilized possess severe toxic and carcinogenic properties. B. The delicate microsurgical instruments are highly susceptible to galvanic corrosion. C. The operational costs of running a single cycle exceed standard department budgets. D. The lack of established industry guidelines requires individualized facility procedures. Correct answer A. Knowledge point explanation. Low-temperature methods utilize hazardous chemicals such as ethylene oxide, EO, and hydrogen peroxide, H2O2, to achieve sterility. Rigorous training is essential because these chemical sterilants are toxic to human tissue, and improper handling can lead to severe staph exposure or leave harmful residues that endanger patient safety. Trap analysis. B is incorrect because while preventing instrument corrosion is a technical skill, it is an equipment maintenance issue rather than the primary human safety reason for mandatory training. C is incorrect because although low-temperature cycles are expensive, financial cost does not dictate occupational safety training requirements. D is incorrect because comprehensive standards do exist, specifically the Association for the Advancement of Medical Instrumentation, AAMI, ST58, which governs these chemical processes. Concept extension. The Occupational Safety and Health Administration, OSHA, sets legally binding permissible exposure limits, PELs, for these sterilants to protect workers during their shifts. Question 2. A sterile processing technician is reviewing the instructions for use, IFU, for a newly purchased flexible endoscope to verify material compatibility before selecting a sterilization method. What does this specific verification ensure? A. That the device will not undergo any adverse functional or structural changes during the chemical cycle. B. That dissimilar metals within the device housing will not interact during high-temperature phases. C. That the medical device has been formally approved by the Environmental Regulatory Agency. D. That the packaging wrap will actively absorb the chemical sterilant to protect the instrument. Correct answer A. Knowledge point explanation. Material compatibility means that the specific chemical sterilant will not degrade, melt, or alter the physical components of the medical device. The sterilizer process must kill the microorganisms without causing the device's lenses to cloud, its plastics to become brittle, or its functionality to fail during surgery. Trap analysis. B is incorrect because high-temperature interaction relates to steam sterilization limitations, not the chemical interactions defined by low-temperature compatibility. C is incorrect because the U.S. Food and Drug Administration, FDA, clears medical devices for market, not environmental agencies, and clearance is distinct from physical material compatibility. D is incorrect because packaging materials must never absorb the sterilant. If they do, they deplete the gas concentration and cause the sterilization cycle to fail. Concept extension. Device manufacturers bear the primary responsibility for conducting rigorous testing to validate which specific sterilization methods and parameters are compatible with their instruments. Question 3. Which of the following low-temperature sterilization methods possesses the superior capability to permeate complex packaging and reach the recessed areas of extremely long, narrow lumens? A. Ethylene oxide, EO, gas sterilization. B. Vaporized hydrogen peroxide, H2O2, sterilization. C. Dynamic air removal steam sterilization. D. High-level liquid glutaraldehyde immersion. Correct answer A. Knowledge point explanation. Ethylene oxide is characterized by its exceptionally small molecule size, granting it unparalleled penetrating power. It is the gold standard for sterilizing complex medical devices with long, narrow, and intricate lumens that other chemical vapors struggle to effectively navigate. Trap analysis. B is incorrect because while H2O2 is effective, its penetrating capabilities are strictly limited by lumen length and internal diameter restrictions as defined by the equipment manufacturer. C is incorrect because dynamic air removal uses high heat and moisture, which disqualifies it as a low-temperature method. D is incorrect because glutaraldehyde is a liquid chemical disinfectant, not a gaseous sterilization method capable of penetrating sealed packaging. Concept extension. Because of its excellent penetration, EO is also uniquely compatible with cellulose-based packaging, like standard paper plastic peel pouches, which are strictly prohibited in H2O2 systems. Question 4. A sterilization load has successfully completed the exposure and exhaust phases in an ethylene oxide, EO, sterilizer. The machine automatically transitions into a prolonged aeration phase holding at 140 degrees Fahrenheit, 60 degrees Celsius. What is the precise purpose of this mandatory phase? A. To actively flush and remove residual toxic gas absorbed by the load materials. B. To break down the chemical vapor into non-toxic byproducts like oxygen and water. C. To thoroughly dry any remaining condensation on the surgical instruments. D. To polymerize the chemical sterilant for safe environmental disposal. Correct answer A. Knowledge point explanation. Aeration is a critical safety mechanism designed to purge the sterilized items of toxic EO gas that has permeated their physical structures. The sterilizer circulates continuous warm air to draw these hazardous residues out, rendering the items safe for patient contact and staff handling. Trap analysis. B is incorrect because breaking down vapor into oxygen and water is the distinct function of the plasma phase in a hydrogen peroxide sterilizer, not EO. C is incorrect because drying condensation is associated with the final phase of a steam autoclave cycle. D is incorrect because polymerization is an adverse reaction where EO turns into a sticky sludge, not a planned phase of the cycle. Concept extension. Under no circumstances should a technician interrupt the aeration cycle to retrieve an item early, as this guarantees a severe chemical exposure hazard. Question 5. Based on material compatibility and sterilization mechanics, which of the following medical items is appropriate for processing in a hydrogen peroxide, H2O2, gas plasma sterilizer? A. Rigid fiber optic telescopes. B. Cotton gauze sponges. C. Powdered hemostatic agents. D. Liquid antibiotic solutions. Correct answer A. Knowledge point explanation. Hydrogen peroxide gas plasma sterilization is specifically designed for moisture-sensitive and heat-sensitive instruments. Rigid fiber optic telescopes, endoscopes, are heat-sensitive and constructed of synthetic materials and metals that are fully compatible with the oxidative killing mechanism of H2O2. Trap analysis. B is incorrect because cotton gauze is made of cellulose. Cellulose absorbs the H2O2 sterilant, causing the chamber pressure to drop and forcing the machine to automatically abort the cycle. C is incorrect because powders cannot be sterilized by gas plasma methods and require dry heat or radiation. D is incorrect because liquids cannot be processed in low-temperature gas systems due to the deep vacuum phase, which would cause the liquids to boil and vaporize. Concept extension. Items processed in H2O2 must be completely dry before loading. Any residual moisture will interfere with the deep vacuum phase and cause the cycle to cancel. Question 6. A technician is preparing to process a newly acquired flexible cystoscope using an ethylene oxide, EO, sterilizer. To determine the exact required aeration parameters, such as holding the item for 8 hours at 140 degrees Fahrenheit, which specific authoritative document must the technician consult? A. The gas cartridge's instructions for use, IFU. B. The sterilizer equipment's default operations manual. C. The medical device manufacturer's instructions for use, IFU. D. The Environmental Regulatory Agency's safety guidelines. Correct answer C. Knowledge point explanation. Because different materials absorb and release chemical gases at different rates, Only the specific medical device manufacturer can validate the exact aeration time required to render their instrument safe for patient use. The technician must always default to the device manufacturer's instructions for use, IFU, for these critical parameters. Trap analysis. A is incorrect because the gas cartridge IFU explains how to handle the sterilant itself, not how long a specific surgical instrument takes to off-gas. B is incorrect because while the sterilizer manual provides baseline cycles, it cannot account for the unique material composition of every instrument on the market. D is incorrect because environmental agencies govern outside emissions, not the specific processing steps for surgical devices. Concept extension. If there is ever a conflict between the sterilizer's default cycle times and the device manufacturer's IFU, the strict rule in sterile processing is to always follow the device manufacturer's IFU. Question 7. During a department orientation on chemical safety, the clinical educator discusses the permissible exposure limit, PEL, for hazardous gases. How is this critical regulatory term formally defined in the workplace environment? A. The maximum validated time an instrument can withstand chemical exposure during a single cycle. B. The absolute minimum duration an employee must wait before opening an active sterilization chamber. C. The highest volume of liquid sterilant legally permitted to be stored within the facility at one time. D. The maximum concentration of a toxic chemical a worker can be exposed to over an 8-hour shift under Occupational Safety and Health Administration, OSHA, regulations. Correct answer D. Knowledge point explanation. The permissible exposure limit, PEL, is a legally binding worker safety standard established by OSHA. It dictates the maximum average concentration of an airborne chemical to which an employee may be safely exposed during a standard 8-hour workday, typically measured as a time-weighted average. Trap analysis. A is incorrect because this describes material compatibility limits for the surgical device, not human safety limits. B is incorrect because opening an active chamber is strictly prohibited by machine safety interlocks, not by PEL definitions. C is incorrect because PEL regulates airborne inhalation exposure, not liquid inventory storage limits. Concept extension. The PEL for both ethylene oxide and hydrogen peroxide is strictly set at 1.0 part per million, ppm. Both require stringent area and personal monitoring to ensure compliance. Question 8. A surgeon requests that a specific set of delicate microscopic eye instruments be processed rapidly using a vaporized hydrogen peroxide, VH2O2, sterilizer. Where must the technician look to definitively verify if these instruments can withstand this specific oxidative process? A. The specific medical device manufacturer's written instructions for use, IFU. B. The facility's safety data sheet, SDS, binder located in the decontamination area. C. The official standards published by the Association for the Advancement of Medical Instrumentation, AAMI. D. The U.S. Food and Drug Administration, FDA, database for cleared medical products. Correct answer A. Knowledge point explanation. The device manufacturer's instructions for use, IFU, is the only legally and scientifically authoritative source for material compatibility. The manufacturer has conducted the necessary laboratory testing to guarantee that the specific sterilant will not degrade the instrument's materials or compromise its functionality. Trap analysis. B is incorrect because the SDS provides emergency first aid and spill cleanup information for the chemical itself, not compatibility data for surgical tools. C is incorrect because AAMI provides general best practices for the department, not specific testing data for individual surgical instruments. D is incorrect because while the FDA clears the sterilizer and the device for market, the specific processing instructions must be provided directly by the device manufacturer via the IFU. Concept extension. Processing a device in a low-temperature sterilizer that contradicts the manufacturer's IFU constitutes off-label use, transferring immense legal and clinical liability onto the healthcare facility. Question 9. A sterile processing technician is loading a cart for an upcoming ethylene oxide, EO, cycle. To guarantee the chemical gas effectively circulates and prevents a sterilization failure, what critical loading error must the technician strictly avoid? A. Placing the biological indicator test pack directly in the geometric center of the load. B. Arranging paper plastic peel pouches on their edge in a metal basket. C. Loading the items with mixed materials compatible with the cycle parameters. D. Overloading the chamber by packing wrapped trays too densely against each other. Correct answer D. Knowledge point explanation. Overloading is a primary cause of low-temperature sterilization failure. If trays are packed too densely, the chemical gas cannot freely circulate and reach all the surfaces of the packages. Furthermore, packages touching the chamber walls can interfere with temperature transfer and damage the wrapper. Trap analysis. A is incorrect because placing the test pack in the center is the correct protocol. It represents the most challenging area for the gas to penetrate. B is incorrect because placing peel pouches on their edge is the proper technique to ensure sterilant penetration and removal. C is incorrect because mixing load items is perfectly acceptable as long as all items are compatible with the specific EO cycle. Concept extension. Proper loading technique requires leaving visible space between rigid containers and wrapped items, allowing the gas to envelop each package entirely. Question 10. A facility's environmental monitoring system detects a chemical leak that raises the ambient concentration of a low-temperature sterilant. Which federal regulatory agency legally establishes the permissible exposure limits, PELs, that dictate when this environment becomes unsafe for the technicians? A. U.S. Food and Drug Administration, FDA. B. Centers for Disease Control and Prevention, CDC. C. Occupational Safety and Health Administration, OSHA. D. Environmental Protection Agency, EPA. Correct answer C. Knowledge point explanation. The Occupational Safety and Health Administration, OSHA, is the federal agency with the legal authority to enforce workplace safety laws. OSHA establishes and enforces the permissible exposure limits, PELs, for hazardous chemicals to ensure employees are not subjected to toxic environments during their shifts. Trap analysis. A is incorrect because the FDA regulates the efficacy of the sterilant on the medical device, not the worker's breathing zone limits. B is incorrect because the CDC provides public health guidelines and infection control recommendations, not legally binding occupational chemical exposure limits. D is incorrect because the EPA regulates the exhaust of chemicals into the outside environment to protect the public, not the indoor limits for the facility's workers. Concept extension. If an OSHA PEL is exceeded, the facility is legally required to immediately implement corrective actions, adjust engineering controls, and provide medical surveillance for the exposed employees. Question 6. A technician is processing a mixed load of delicate plastics in an ethylene oxide, EO, sterilizer. To determine the exact number of hours required for the mandatory aeration phase at 140 degrees Fahrenheit, which specific document must the technician consult? A. The EO gas cartridge's instructions for use, IFU. B. The sterilizer machine's IFU. C. The device manufacturer's IFU. D. The official website of the U.S. Food and Drug Administration, FDA. Correct answer C. Knowledge point explanation. Core rationale. Because different plastics and polymers absorb and release toxic ethylene oxide gas at different rates, only the specific device manufacturer can scientifically validate how much aeration time is required to make their instrument safe. Therefore, the device manufacturer's instructions for use, IFU, is the ultimate authority for aeration parameters. Trap analysis. Option A is incorrect because the cartridge IFU explains how to handle the chemical, not how devices absorb it. Option B is incorrect because while the sterilizer IFU provides default cycles, the device IFU always overrides it if a longer time is required. Option D is incorrect. The FDA clears the device but does not host individual aeration instructions for daily reference. Concept extension. If a sterilizer defaults to 8 hours of aeration but a specific cardiac catheter's IFU demands 12 hours, the technician must set the cycle to 12 hours to prevent patient chemical burns. Question 7. What is the precise definition of a permissible exposure limit, PEL, in the context of low-temperature chemical sterilization? A. The maximum amount of time a medical device can safely undergo sterilization exposure. B. The maximum amount of chemical sterilant an instrument can absorb before degradation occurs. C. The maximum amount or concentration of a chemical that a worker may legally be exposed to under occupational safety regulations. D. The minimum mandated environmental temperature required to vaporize a liquid chemical sterilant. Correct answer C. Knowledge point explanation. Core rationale. A permissible exposure limit, PEL, is a legally enforceable worker safety standard set by the Occupational Safety and Health Administration, OSHA. It strictly defines the maximum concentration of a hazardous airborne chemical, like EO or H2O2, that a technician can be exposed to safely, typically calculated over an 8-hour time-weighted average, TWA. Trap analysis. Option A is incorrect because device exposure time is an efficacy parameter validated by the manufacturer, not a personnel safety limit. Option B describes material compatibility limits, not occupational exposure. Option D describes the physical thermodynamics of the sterilization machine, completely unrelated to human exposure limits. Concept extension. Both ethylene oxide and hydrogen peroxide currently share a very strict OSHA PEL of exactly 1.0 part per million, ppm, calculated as an 8-hour TWA. Question 8. A new multi-channel flexible endoscope arrives in the sterile processing department. Before deciding whether to route it to the hydrogen peroxide, H2O2, sterilizer or the ethylene oxide, EO, sterilizer, where must the technician verify its material compatibility? A. On the Chemical Sterilants Safety Data Sheet, SDS. B. On the official U.S. Food and Drug Administration, FDA, device registry. C. In the comprehensive standards published by the Association for the Advancement of Medical Instrumentation, AAMI. D. In the specific medical device manufacturer's instructions for use, IFU. Correct answer D. Knowledge point explanation. Core rationale. Only the manufacturer of the medical device has performed the rigorous scientific testing required to guarantee that a specific chemical sterilant will not damage their product's materials, e.g., plastics, adhesives, optical lenses. Therefore, the device's instructions for use, IFU, is the exclusive, definitive source for compatibility information. Trap analysis. Option A is incorrect because the Safety Data Sheet, SDS, only provides emergency spill and human toxicity information for the chemical itself. Option B is incorrect as the FDA clears the device but does not act as a daily reference library for processing instructions. Option C is incorrect because AAMI provides broad industry best practices, not brand-specific material validations. Concept extension. Guessing compatibility can lead to catastrophic instrument failure. For instance, processing an incompatible scope in hydrogen peroxide may cause the insertion tube to immediately melt or become rigid. Question 9. A sterile processing technician is preparing to run a low-temperature sterilization cycle at the end of a busy shift. To ensure the sterilant gas can properly circulate and contact all internal and external surfaces of the packages, what must the technician absolutely avoid doing to the chamber? A. Loading the chamber long before initiating the cycle. B. Overloading the chamber beyond its validated weight and volume capacity. C. Loading the chamber with mixed types of compatible instruments. D. Unloading the chamber immediately upon successful completion of the cycle. Correct answer B. Knowledge point explanation. Core rationale. Overloading a low-temperature sterilizer prevents the chemical gas or vapor from diffusing evenly throughout the load. If items are packed too tightly together, the sterilant cannot physically reach the microbial bioburden on the center packages, guaranteeing a catastrophic sterilization failure. Trap analysis. Option A is not a direct cause of sterilization failure, though leaving items sitting for extended periods is poor workflow practice. Option C is fully acceptable and standard practice, provided all items are compatible with the specific sterilant and cycle parameters. Option D is incorrect because unloading promptly is expected and safe, provided all aeration or venting phases have finished. Concept extension. Proper loading requires distinct spacing between items. In hydrogen peroxide systems, overloading can also cause the cycle to abort automatically because the densely packed items absorb too much energy or sterilant vapor, causing a dangerous pressure drop. Question 10. During an annual safety orientation, the environmental health officer quizzes the sterile processing staff on federal regulations. Which specific agency is legally responsible for establishing the permissible exposure limits, PELs, for highly toxic low-temperature sterilization methods? A. The U.S. Food and Drug Administration, FDA. B. The Centers for Disease Control and Prevention, CDC. C. The Occupational Safety and Health Administration, OSHA. D. The Environmental Protection Agency, EPA. Correct answer C. Knowledge point explanation. Core rationale. The Occupational Safety and Health Administration, OSHA, is the sole federal agency mandated to protect the American workforce. It enforces legally binding regulations, including the permissible exposure limits, PELs, to ensure technicians do not inhale dangerous concentrations of toxic gases like ethylene oxide. Trap analysis. Option A is incorrect. The FDA ensures the sterilizer effectively kills bacteria and doesn't harm the patient, but does not police worker exposure limits. Option B is incorrect. The CDC issues infection prevention guidelines but has no regulatory power over workplace chemical exposure. Option D is incorrect. The EPA governs how the hospital exhausts chemical waste into the outside environment, not the air quality inside the decontamination room. Concept extension. If a hospital's air monitoring shows that the EO concentration has reached OSHA's action level, 0.5 ppm, the facility is legally required to implement aggressive medical surveillance and safety interventions for its staff.